Welcome. This is the YouTube video week 4 assignment. My name is Jonas and I'm glad you are watching. Cryptographic hashing is another fundamental piece of blockchain technology and is directly responsible for producing immutability, one of blockchain's most important features. Hashing is a computer science term that means taking an input string of any length and producing a fixed length output. It doesn't matter if the input to a certain hash function is 5 or 120 characters, the output will always be the same length. So cryptographic hash functions are hash functions that have these crucial properties. First, they are deterministic. So no matter how many times you give the function a specific input, it will always have the same output. The second one is irreversible. It is impossible to determine an input from the output of the function. And the last one being collision resistant. No two inputs can ever have the same output. Another important feature of cryptographic hash function is that changing any bit of data in the input will drastically alter the output. For example, the hash outputs of 11 and 12 would be completely unique and have no relation to each other. The most widespread use case for cryptographic hash function is password storage. Most websites do not store your raw passwords. They store a hash of your password and simply check if the hash matches when you enter it on a given site visit. If a hacker breaks into their database, they will only have access to the irreversible password hashes. So how does cryptographic hashing enables immutability for blockchain technology? The answer is that every new block of data contains a hash output of all the data in the previous block. This is done with hash pointers. So, a data structure is a specialized way of storing data. There are two data structure properties that are critical if you want to understand how a blockchain works. They are first, pointers, and second, linked list. So now we're going to talk about the pointers. Pointers are variables in programming which store the address of another variable. Usually, normal variables in any programming languages stores data. Pointers, however, instead of storing value, will store addresses of other variables, which is why they are called pointers, because they are literally pointing towards the location of other variables. So, now we talk about linked lists. A linked list is one of the most important items in data structures. It is a sequence of blocks, each containing data, which is linked to the next block via a pointer. The pointer variable in this case contains the address of the next node in it, and hence the connection is made. The last node has a null pointer, which means that it has no value. One important thing to note here: the pointer inside each block contains the address of the next block. This is how the pointing is achieved. So now you might be thinking, what does this mean for the first block in the list? Where does the pointer of the first block stay? The first block is called the genesis block, and its pointer lies out in the system itself. This is what the structure of a blockchain is based on. A blockchain is basically a linked list. The blockchain is linked The blockchain is a linked list which contains data and a hash pointer, which points to its previous block, thus creating the chain. So, what is a hash pointer? A hash pointer is similar to a pointer, but instead of just containing the address of the previous block, it also contains the hash of the data inside the previous block. This one small tweak is what makes blockchain so amazingly reliable. Imagine this for a second. A hacker attacks the third block and tries to change the data. Because of the properties of the hash function, a slight change in data will change the hash drastically. This means that any slight change made in block 3 will change the hash which is stored in block 2, which will result in changes in block 1 and so on, and so on. This will completely change the chain, which is impossible. This is exactly how blockchain achieves its immutability. So, a block header contains version, so the block version number, the time, so the current timestamp, the current difficulty target, the hash of the previous block, the nonce, and the hash of the Merkle root. So now we're going to talk about a Merkle tree. A Merkle tree is a computer science term for storing data in a hierarchical tree-like structure where bits of data are called nodes. There's a single root node that has child nodes linked under it, which themselves have child nodes, and so on. Groups of nodes within the tree are called subtrees, and a node with no children is called a leaf node. A Merkle tree, or also called a hash tree, is a tree that utilizes cryptographic hash functions to store hash outputs instead of raw data in each node. Each leaf node consists of a cryptographic hash of its original data, and every parent node is a hash of the combination of its child node hashes. The Merkle root is simply the root node of a Merkle tree, meaning it represents a hash output of the combined hashes of the left and the right subtrees. So why are Merkle trees important for blockchain? So each block contains thousands and thousands of transactions. It will be very time efficient to store all the data inside each block as a series. Doing so will make finding any particular transaction extremely cumbersome and time consuming. If you use a Merkle tree, however, you will greatly cut down the time required to find out whether a particular transaction belongs in the block or not. So, this was my video. I hope you enjoyed it. Thank you for watching.